Hello everyone, my name is Sonia and my team members are Achal, Rishika and Satyam, and our project is sign language recognition. As we all know, human is a social animal. We all use speaking as a mode of communication. Communication consists of two parts, speaking and listening. But there are a lot of people who cannot speak or listen due to various reasons. They use sign language. Sign language is a technique where we use hand gestures and facial expressions to express our ideas and thoughts. Here we have shown some simple ASL sign languages. As you can see, the simple ABCD of ASL sign language. To bridge this gap, we have developed machine learning model that can be trained to recognize and interpret the sign language. We have worked with American Sign Language here, but there are a lot of different sign languages in the world. It is based on hand gestures and facial expressions. It is little different from English grammar and depends on word orders. Deaf and dumb people use sign language for communication. Sign language recognition recognizes the hand gesture and translate it into text using various algorithms. Over to me, Achal.
So there are various sign language recognition methods. So we are following computer vision based method, but there are others also like glove based method, appearance based method, or appearance based method with glove marker. So the methodology we are following is data acquisition, pre-processing the image, feature extraction, classification, gesture recognition, predicting the gesture. So data acquisition is basically converting the physical phenomena into the digital form so that it can be manipulated by the computer. And pre-processing the image means we are removing all the noises and preparing the image for the recognition. Feature extraction is basically the way to extract the feature which we are going to use in our system. Classification involves the identification and categorization of different sign languages gestures. Gesture recognition is the main part in which we recognize a gesture which is already stored in our database. So we will be connecting those two. Predicting the gesture is the output of our application in which we recognize the particular letter made by the user, so it can be recognized by the other people and can bridge the gap between the dumb people and the people who can speak. Over to you, Rishika.
So for building the model, we have used following tools and dependencies. Keras, which is an important library in our project. It provides us with deep learning framework. And from this, we have used convolutional neural network. It is a very dynamic library and it has provided us with extensive functions. OpenCV provides the vision to the computer. The signs and the gestures that we make are sensed by the camera present on a laptop. So that is processed by OpenCV. Basically, it's a image processing tool and it provides vision to our computer. Jupyter is the environment where we have built a model and trained a model. Steps to build a sign language recognition model using CNN. Importing the necessary libraries. As you can see, here we have Keras, NumPy for normal array processing, CV2 for involving various convolutional layers, max pooling, etc. And the data set that we have adopted is the NIET data set, which we found on Kaggle, which consists of images of various gestures. The 3D image was converted into 1D data. As you can see, we have labels, pixels, and we have color values also. And this data set was later pre-processed by us using NP array, where we reshaped our data set for future model training. Designing the CNN architecture. Since we had the 1D data, that data was converted into 3D image, and the color factor, the RGB factor, was converted into gray. So there was RGB to gray conversion. We have used Gaussian blur filter, and this data was later then fed into the convolutional layer. We had added 2 convolutional layers with kernel size of 3 by 3 and strides of 1. Also, we have added ReLU. ReLU stands for Rectified Linear Unit. Max pooling was also done, and the pool size was 2x2. And the dropout layer, which we added, enhanced the accuracy of a model even more. Compiling the model, we have run our model for 50 epochs. And as you can see from the screenshot that we have attained an accuracy of about 93%. And the final accuracy that we got from this model was around 94%. Later, then this model was trained and we have evaluated and found that the accuracy was around 94.08% and making the prediction. So we provided vision to a computer, created an OpenCV window for the predictions, and we've trained the model, and on that trained model we have predicted in the real time, and a model was giving confidence level of around 88 to 86%, provided that the conditions and the lighting of the room is okay. And also we have to use the right hand since the data was very limited. So it is required that the user uses the right hand to show the gestures. Fine tune and optimize. Yes, we have done certain optimizations to a model, like we have added the dropout layer. Earlier it was not there. So we have found that it increased the accuracy of the model even further. Architecture of the CNN gesture recognition model. CNN follows a basic architecture. We have to provide convolutional layer. Convolutional layer are followed by activation functions like ReLU, softmax, TANH. We found that the ReLU gave a better accuracy, so we have adopted that. We have adopted dropout layer also. Dropout layer means it drops the features that are not very relevant and obtains the features that are more required. And then we had a pool max function. Pool max function was used to study the important features that are present in our image. And later this image data was used to train a model. Various layers of CNN. CNN consists of convolutional, pooling, and fully connected layers. Fully connected layers are hidden layers which are present in the model itself, and they adjust their weight according to the patterns that they are fed with. This is the diagram which shows how gesture recognition is taking place, and this is the training part of a model. Result, our model exhibits a promising accuracy of 94% on the training and the testing data set, but in real time, it shows the accuracy of around 84 to 88%, required that you are in proper lighting conditions. Now I'll hand over this to my friend Satyam.
We are facing many problems, many challenges for creating this project. First, web cameras cannot work properly and images are blurred. There are a number of problems with data collecting for sensor, including noise, bad human handling, improved ground connection, and others. The lack of readily available huge dataset make it difficult to train an SLR system. Isolated SLR technique and demand time consuming word by word labeling. Scope voice integrated sensor gloves to recognize sign language motion, smart glasses integrated with SLR software and SLR mobile app. Conclusions are: this project presents a real-time sign language recognition system developed using the TensorFlow object detection API. The system successfully translates sign language gesture into commonly spoken language, addressing the communication barriers faced by individuals with disabilities, while achieving an average confidence rate of 94%. There are opportunity of future improvements. Opportunity for future improvements such as expanding the dataset and exploring alternative models. By connecting the advance the capabilities of a SLR system, we can foster inclusive, empower individuals with disabilities, and enable effective communication across different sign language. Now, Riska, so demos.
Now let me take you through the code walkthrough. This was the data set which we have taken from Kaggle. It consisted of pixelated images, As you can see, here's the pixelated data. This 2D data was converted into 1D array, which we have pre-processed further to make into the 2D picture. This is the main ASL with CNN file where we have trained our model using convolutional neural network. Here are all the important imports. The data set was imported, splitting was done, labels were separated, and this is the main part where we have created the convolutional layer, the max pooling layer, the dropout layer, and we have also flattened the image. And we have given 50 epochs, which means 50 runs, and we have found that the accuracy, the average accuracy that was found was 93%. Here's the model summary. This model was saved into an H5 file, which consists of all the model parameters and everything which was saved during model training part. Then this file was used to train our model, which this script consists of OpenCV window where we have feeded our model, and a real-time window was created wherein we showed the gestures, and the output was shown on the screen. Now let me run the code. As you can see, I have to place my hand in this blue box. And when I show, this is the sign for W. And when I show this, the W is shown on the screen. Now I am creating gesture of O. And this stands for O for ASL sign language. And this is C. So this is how our model works, and it gives a confidence level of 88% in normal lightning conditions. Thank you.